Hey there, everybody. Purpose of this video is to get you some solutions to our little homework here on radicals. So there's a lot of reading here, and I'm guessing you read most of it because you all did really, really well on it. So I'm just going to walk you through the actual exercises. Most of it is honestly a little bit of dimensional analysis, but most of it is just making sure that you can run square roots through Google. So here's the square root of 38.2. We'll just crack open this. Square root of 38.2, which gets us about 6.2. I mean, if you round it off to that, 6.2. So that means if you took 6.2 and squared it, you'd get 38.2. Now, that's not exact. I mean, this number goes on forever. So if you actually did do 6.2 squared, you wouldn't get exactly back to 38.2. You got 38.44. But now we're really getting into this. With that kind of discussion, we're getting into an accuracy, precision discussion, which is to have for another time. Root 153. The root of the room number our son was born in, 153. That's going to be about 12.4. That gets you back to 153. And then root of 3/10. Whoops, wrong. It's over here. There we go. Root of 3/10 ends up being 0.55 or 0.5, depending on what you're rounding off to. Okay, we'll come back to that one in a second. Okay, so I mentioned a bunch of other roots, which we'll get to in Math 105. The only real time we're going to use radicals in a different application is with this Pythagoras idea, which we'll see as we sprinkle. You'll see it sprinkled through Math 98 and then into 105 too. So I'm giving you an example of just building this shelf and having to figure out how long this diagonal needs to be. So the question really is, we need to figure out the value of this thing here. Now we already did it up here in the previous part of the homework, so we know it has to equal 11.3. So I gave you 3 series of steps to see which one equals 11.3. So let's look at this first one. Squaring the 8's first, then taking the square root of those 64s, then adding the results together. Okay, so let's say we do that. Let's do the squaring. So 8 times 8 is 64. 8 times 8 is 64. 64 plus 6, taking the square root of those 64s, which would knock it back down to 8. 8 plus 8 is 16. Well, that doesn't work. We can't use that one, because that equals 16. Canceling the exponents of 2 with the square root, then adding the 2 eighths, well, that also doesn't work. That also is going to give you 16. Squaring the 8's first, then adding the results of that together. So 8 squared is 64, plus 8 squared is 64. 64 plus 64 is 128. Last thing you would do would be to take the square. That's exactly it. It's that one right there. That's the one you need to do right there. The very last one over here. And that's why I introduced this new order of operations, better revised revision for reals. And the reason there is just because even though you don't see parentheses around the numbers under a square root, they are there. You have to do that operation first before anything else happens. So even if this is just simple addition, not even involving exponents or anything else, you still have to do it first, just like we did with parentheses with fractions. Okay, you're going to notice that's why you never hear me say, please excuse my dear Aunt Sally. You ever hear me say that, because there's so many things under parentheses besides just parentheses themselves. And then here I just wanted you to put these into Google. So you got 32.3 and 19.4. So that's a square root of, you know what? I'm going to teach you something new here. SQRT is the square root function. And then what we can do once you do that, because what I'm 32.3 squared plus, I think it was 19.4, is that right? 0.4 squared. So check out what I just did there. I wrote the square, we talked about this in class. I wrote the squared as a power of 2, and then I just took square root is just the function for square root. End up getting about 37.7. Okay, you can also probably type it square root of, yep, that works too. Now watch what happens here. Watch what happens if I take the parentheses out. I get the wrong answer. And the reason is, Google says, okay, this is telling me to take the square root of this, and then whatever I get there, actually that's not even, what the hell is it doing? Oh, yeah, it's doing exactly that. My bad. It's doing the square root of this and then squaring this and then adding that big old number on. That's about 400 right there. So it's taking 400 plus the square root of this. So that's not correct. You have to make sure, again, parentheses group the roots. That's why that one's there. And then last but not least over here, this was just a fun one. You can stack as many of them together as you want. So I did 5 squared, 6 squared, and 7 squared. So you already learned. I'm gonna have some fun with this. I'm gonna type it 5 squared plus 6 squared plus 7 squared. Let's see if it can handle that. It sure can. So it can actually understand the words as well as the math. But again, remember, you need the parentheses, because if you don't use the parentheses, what it's going to do is it's going to take the square root of 5 squared, which is 5, plus 6 squared, that's 5 plus 36 is 41, plus 7 squared is 49. 41 plus 49 is 90. So you have to make sure you group all that stuff there. All right, 10.5. This last one down here, go back to the first example. Suppose the units on those 8s are inches. Please explain why the units on the 11.3 are also inches. And we talked about this in class. It comes from the same reason that the square root inverts or removes the squares. So you don't see it when you're doing the math, so to speak. You don't see it. That's why we wrote it on the board here. So the thing is, when you square a number, the number is multiplied by itself. But if that number itself has a unit attached to it, that means the unit has to be squared too. So let me see if I can explain this by typing. So let's just, I'm going to take out this. I'm going to toggle this. And I'm going to replace this with 8 squared plus 8 squared. Okay, because that's really what the original problem is. But that's where it gets interesting, because it really isn't 8. It's 8, I don't know if I can do this, inches squared. I'm going to try something. It might not work. Let's see if it might give me an error on this. And if it gives me an error, I'll do it a different way. Yeah, oh, it worked. Okay, that worked just fine. So you're taking 8 inches and multiplying it by 8 inches. And we drew a little graphic in class today about why 8 inches by 8 inches multiplied together gives you 64 square inches. Just like 8 times 8 is 64, inches times inches is square inches. So this ends up being equal to, let me toggle this, 64 square inches plus 64 square inches. Okay. And then you can add square inches to square inches, just like you can add 64 to 64, and you're going to end up getting 128. Oops, I got to get in here and toggle it again. 128 square inches. Now here's where the units come in. When you took the square root of 128, you ended up with 11.3, and the logic there is because 11.3 times 11.3 equals about 128. That's great. But the unit also has to have the radical applied to it. The inches are under the radical. That means you have to figure out a unit so that the unit times the unit equals square inches. So what unit times itself equals square inches? Hopefully that makes sense, that it's just going to be inches. I mean, you have to get a unit times itself that'll equal square inches, and that's going to be exactly the one you get right there. So hopefully that makes sense. You might notice that in every example you did today, the number under the square root symbol was always larger than the square root of the number, except for the square root of 0.3. Remember that one? That was the one where you took the square root of 0.3, it went to 0.5, I think. Square root of 3 tenths. And it ends up being 0.55, right? Okay, and I asked you to explain why that is the case. And what I wanted you to think about was what happens when you take a number like 0.3 and multiply it by itself. Okay? So if you think about a number like 0.3, and the reason I'm saying 0.3 is it's a number between 0 and 1. It's a fraction in the most kind of, I'm going to use a word from your old math classes, proper form. And a proper fraction, and I hate to use that because that implies that there are things called improper fractions, which there are, but for all the wrong reasons. Anyway, a proper fraction has a numerator that's smaller than its denominator. So like a half, 2/3, 5/6, things like that. If you take a number like a half and multiply it by itself, it actually gets smaller. Right? A half times a half is a quarter, right? Let's go back to Google so you can see, 1/2 times 1/2 is a quarter. It gets smaller. A quarter times a quarter is a 16th. It gets smaller. So in order to take the square root of something and get that something to be a decimal between 0 and 1, the number that you start with actually has to be larger, because you're going to multiply it by itself and it's going to get smaller. So to end up with something like 0.3, you can't have something like 0.2, because 0.2 times 0.2 is going to end up being smaller than what you started with. So you have to end up with larger numbers. And that's why when we back up far enough, we see that the square root, oops, I just saw it right there, 3/10 is 0.55, because when you actually take this number, which I will take right now, and square it, you actually get back to essentially 0.3. That rounds off to 0.3. So you have to start larger, because when you square it, it's actually going to get smaller. Hopefully that makes sense. It was extra credit. That's definitely not a simple question. That's why it was extra credit. All right. Hope it made sense, and we'll see you in class.